All right, this is Chapter 1, Section 2 on piecewise functions. And a piecewise function, it's exactly what it sounds like. It's a function that has more than one piece to it, or more than one part. So each piecewise function is going to have more than one equation, and each equation represents one part of that graph. Now, after each equation comes a domain. So this is where it ties in with what we just talked about in 1.5 Part 2. When we did restricting the domain, you saw an equation and then it said comma and there was a domain on it. The domain told you when to use that equation. So here's what a piecewise function could look like. Here's an example of one. This is a nice simple one. It's a piecewise function that has two parts. One part is right here. And it's basically like saying f of x equals 3x plus 4. Then, right here, that's the domain. That tells you when to use it. So you only use that equation if x is less than or equal to 1. Then right here, you have the second piece. And this says f of x equals x minus 1. And you're only going to use that equation when x is greater than 1. All right. So our main focus for today is going to be graphing piecewise functions. And if you want to graph a piecewise function, you always want to graph each part separately. If there are two pieces, it's two separate problems. If there's three, it's three. If there's 10 pieces, it's 10 separate problems. There's no shortcuts. You just got to do each part separately. Now, the best way to do it, especially if there's 3 or 4 or 10 parts, the best way to do it is to graph the entire thing and then erase the part that you don't need. Now there's one extra step here. When you're doing these piecewise functions, you're going to be drawing this graph and it's going to be going, 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 and then all of a sudden it's going to stop. It's going to stop right somewhere. It's going to cut off. Now at that place where it cuts off, you either want to end it with an open circle or what we call a closed circle, or basically a dot, a filled in circle. Now the filled in circle means this is an actual point on the graph. The open circle means it's not the point on the graph. And the way it works is, if you look at the domain part, the inequality part, if it has the or equal to, then that's a point on the graph, and you use the filled in or closed circle. If it does not have, if it has a greater than or a less than without the or equal to, then you use the open circle. So let's go ahead and try one out. For our first example, we are going to graph the exact same one we just looked at. So we're going to treat this as two separate problems, and actually before I do anything else, I always like to look over here at this number here. That's where x equals 1. And I'm saying I have one graph, don't worry about the or equal to yet, but basically I have one graph that I'm doing where x is greater than 1 and one where it's less than 1. So what I'm going to do is I'm just going to draw in this dotted line at x equals 1 right here, because that's where my graph is going to split in half. Now on the right hand side of that dotted line, that's all the numbers that are greater than 1. And on the left hand side is where x is less than 1. So let's do each of these equations one at a time. Let's start with the top equation. Y equals 3x plus 4. Now as a quick review for you guys, when you're graphing a line, it's y equals mx plus b, and b is the y-intercept. So since b is positive 4 in this one, from the center I'm going to count up 1, 2, 3, 4, and I'm going to put a point right here. Then the slope is the number in front of x, which is 3. Now if the slope is a whole number, you can put it over 1, and you always want it to be a fraction because we're going to do rise over run. So if my slope is positive 3, basically from the first point, I want to go up 3 and right 1. So up 3, right 1 will put me right there. And you really only need 2 points. 2 points make a line. So I'm going to draw this line going through those. Just like that. Okay, now, once I've drawn the graph, I go back to the domain. And I say, don't worry about the or equal to part. You're looking less than or greater than. So this is x is less than 1, which is on the left-hand side, which means I want to keep the part on the left, but anything to the right of that dotted red line, I want to get rid of. So I am going to erase all of that. Actually, I have to redraw part of it. But I want it to basically stop right there at the dotted red line. Now the last step is to decide what happens on the dotted red line, open or close circle. And because this one has the or equal to in it, it's a point. I'm going to put a closed circle or a point right there. So I am exactly halfway done with this problem. I'm completely done with the first equation, and now I have to do the same thing with the second one. So the second equation is y equals x minus 1. So for the second equation, and we're just starting over, do the exact same thing. The y-intercept this time is -1, which would be right here. The slope is actually 1. If you have an x by itself, it means 1x. And if you want to turn that 1 into rise over run, you put it over 1. So basically, it's 1 over 1. So from my first point, my light blue point there, I go up 1 and over 1. It would be right here. And then I get this line going like this for my second one. Then I look at it and I say, the domain was x is greater than 1, so this time I want to keep everything to the right of that line and get rid of everything to the left. So we are going to erase this part. I can erase that point there too in the middle. And then because this one did not have the or equal to in it, I'm going to put an open circle there on the end. So what you want to do, you want to make sure nothing ever overlaps, because then it wouldn't be a function. You don't want to have two functions that are on the same side of that dotted red line, because it would fail the vertical line test, it would not be a function. You also don't want to have two closed circles on the dotted red line, because that's two outputs for one input and it's not a function anymore. So you always, if you have more than one thing ending on a line, you can only have one point there. You can't have two filled in circles on the same vertical line or it's not a function. So let's try one more example. I want to do a three-part piecewise function with you guys, and I also want to tie in some of our familiar functions from when we did transformations. All right, let's start this question off the same way I did before. Now what I notice here is I have one key value at -2, which would be right here. And then I have another key value in the domain at +1, which would be right here. So now, because I have those two values, I've split my graph into three parts, and that's what we need because you can see we have three equations in it. So let's do each one at a time. The first one is absolute value of x. That was from our library of functions from day 1 of class, and that's that perfect V shape. So it would look kind of like this. There's my absolute value graph. Now I go back to my domain, and I say this is for x is less than -2. That's the one all the way to the left. Less than -2 means to the left of my very first line. So what I want to do is get rid of this part on the right and this part in the middle. And I only want to keep the part on the left. Then I look right here and I say that inequality did not have an or equal to, so I'm going to end up with an open circle on the line. And I'm completely done with my first part. I graphed absolute value of x, used the domain to keep the part I needed, and then I decided between open and closed circle. All right, let's do the next one. The next one is x squared. Now x squared is a parabola centered right in the middle. So it's going to look something like this. And then I say, all right, well, I look at the domain. This time, I want to keep the middle part. That double inequality means x is between -2 and +1. So I want to just keep the middle part, and I think this is not going to work with my eraser very well because I drew it all as one piece. Yeah, it's basically going to get rid of everything for me, but it would have worked better if I had done it like, would look something like this. So there's just the middle part of my parabola. I got rid of the part on the left, I got rid of the part on the right. Now here's where you want to be real careful, because between the x and the -2, I have the or equal to. So on the -2, I have a closed circle. But between the x and the 1, I do not. So on the negative, or on the +1, I have an open circle. So with the double inequalities, you want to be very, very careful. The number it's connected to is the one that you're using. Between the x and the -2, I had an or equal to. So on -2, closed circle. Between the x and the 1, no or equal to. So on the 1, open circle. Okay, now our last one is the easiest one, but it's also, sometimes easy can be confusing. You think it's a trick question, it has to be harder. When you just see a number here, 2, that's just y equals 2. And y equals 2 is a perfectly horizontal line. Whenever you have a constant for your function, that's a perfectly flat line. So I have a line at y equals 2. I'm only doing it where x is greater than or equal to 1. And I'm not going to draw any race because this is an easy one. I'm basically just going to do this. That's my perfectly horizontal line at y equals 2. I only kept the part where x is greater than 1. And I actually set this example to work this way on purpose. What happens is, because I have the or equal to, I'm supposed to fill in that point. But there's already an open circle there. That doesn't matter. If you ever end up with a closed circle on top of an open circle, it just fills it in. So you don't have to do anything special. You don't have to draw a closed circle with an open circle around it or something like that. I've seen students do that in the past. A closed circle on top of an open circle is just a closed circle. So this is our final answer. The green one was the absolute value one. The blue one is x squared. The purple one is y equals 2. It's called a constant function. The three together are our piecewise function. So that's a quick review for you guys on how to work with piecewise functions, and we focused on how to graph them. As always, if you have any questions, email me and we'll answer questions from the homework tomorrow in class.